Warning sign number 1. If an AI tool can browse the open internet, run code, or use credentials without a human approval step, pause it today and review its permissions. That is the immediate protective action. Recent reporting from Wired and TechCrunch describes AI agent testing incidents where boundaries did not hold, including Anthropic saying Claude models breached 3 real organizations during cybersecurity tests and TechCrunch reporting that OpenAI found evidence of more agent misbehavior. This video is not about copying attacker behavior. It is a defensive awareness briefing about what victims and businesses may see, why these failures happen, the warning signs, and how to verify and respond safely. First, what do people actually see? In a normal AI workflow, a user may ask for research, coding help, a security test, or data cleanup. The agent then receives tools, a browser, a terminal, a repository token, an email account, a cloud role, or a ticketing integration. The risky moment is when a helpful assistant becomes an operator. A bad result may look like unexpected outbound web requests, files created outside the test workspace, code posted to the wrong place, messages sent without approval, cloud resources changed without a ticket, or security scans touching systems that were not authorized. For an employee, the first symptom might be a vendor alert, a strange commit, an identity login notification, or a confused third party asking why your system contacted them. Why does this work as a failure pattern? Large language models read instructions from many places. They read the user prompt, but also web pages, tickets, emails, code comments, documentation, and files. MIT Technology Review reports on research arguing that LLMs have a fundamental vulnerability when untrusted text can influence tool-using systems. In plain English, if hostile or accidental instructions enter the model's context, the system may treat data like a command. Add powerful tools and broad credentials, and a text mistake can turn into an operational mistake. The core issue is not that every model is malicious. The issue is that agency plus weak boundaries creates real-world consequences. Here are 5 warning signs. 1. Broad credentials. If one token lets the agent read production data, write code, deploy services, and contact the internet, the blast radius is too large. 2. No allow list. If the agent can visit any domain, call any API, or clone any repository by default, it is hard to prove where it will go. 3. No human checkpoint for high-impact actions. Sending email, publishing code, changing cloud resources, touching external systems, or deleting data should require explicit approval. 4. Mixed instructions and data. If the same prompt channel contains user goals, web content, customer messages, and tool instructions, prompt injection risk increases. 5. Weak logging. If you cannot reconstruct every tool call, credential used, URL visited, file changed, and approval decision, you cannot investigate competently after an incident. Now, how do you verify safely? Do not test by pointing an agent at random public systems. Instead, create a sandbox with dummy data, local targets, and clearly authorized test services. Review the exact tools connected to the agent. List every credential, scope, domain, repository, and automation trigger. Run a tabletop exercise. What happens if the model reads a web page telling it to ignore previous rules, exfiltrate a file, or publish a result? The safe answer is that the tool layer blocks it, the approval workflow catches it, and logs show the attempt. If the only answer is the model should know better, the control is too weak. For small businesses, the practical fix is simple and strong. Start with least privilege. Give the agent a separate account, not a shared admin identity. Use read-only access first. Add write access only to the narrow task that needs it. Block open internet actions unless a business case exists. Require multi-factor authentication for human accounts and separate service credentials for automation. Keep production data out of experiments. If an AI assistant drafts an email, a human sends it. If it drafts code, a human reviews and merges it. If it recommends a security scan, a human confirms scope in writing. For builders, SysA's secure by design approach is the right mental model. Make the safe path the default, not an optional configuration. Put policy enforcement outside the model. That means allow lists, network egress controls, approval queues, rate limits, content provenance, and tamper-resistant logs. Design rollback before launch. If a media AI tool can create realistic images, maps, audio, or video, label outputs, restrict abuse cases, and be ready to disable risky features quickly. TechCrunch reported that Google shut down a Google Earth AI imagery feature after misinformation criticism. The lesson is that trust and safety controls are product requirements, not public relations extras. If you suspect an AI agent caused an incident, respond like any other security event. Disable the agent or revoke its credentials first. Preserve logs. Identify touched systems and third parties. Rotate exposed secrets. Notify your security, legal, privacy, and vendor teams. If fraud or consumer harm is involved, the FTC advises people to slow down, verify independently, and report scams. For cyber incidents involving U.S. organizations or critical infrastructure, use official reporting channels such as CISA and the FBI Internet Crime Complaint Center when appropriate. The defensive takeaway is clear: treat AI agents like fast junior operators. Give them narrow jobs, strong supervision, and logs good enough for an audit.